This is the Makera Carvera Air, a CNC machine in a very compact package. And in this video, I'm going to take you guys through the unboxing, the setup, show you an accessory that I designed for this machine, and of course, we're going to test it with two full projects, one in acrylic, the other in aluminum, and I'll walk you through the entire process from start to finish, including all of the software, and at the end of the video, I'll give you guys my final thoughts on the Carvera Air. And if at any point you're considering getting a Carvera Air for yourself, use the links in the video description down below. They are affiliate links and they cost you nothing extra, and they go a very long way to supporting this channel and supporting all of the work that goes into these very long and thorough videos. Let's go. We'll begin with the unboxing, and the Carvera Air is pretty heavy, so if you're getting this thing up on a table, you may want to get some help from a friend. And right when you open the box, you get a guide telling you how to unbox the product, so we'll go ahead and follow that. We'll pull the machine out of the box and remove all of the plastic wrapping. Pretty much everything is contained right inside of the machine, so we can lift the front cover and we can remove the styrofoam, and you'll see nested inside all of the accessories. And these are neatly packed into several different boxes. And in the first box, what we'll find is the 4th axis kit. And this piece here is an optional add-on, and I won't be covering it in this video as we have enough to get through, but keep an eye out for a second Carvera Air video on my channel, because this is something I really want to show you guys, and it's made of solid metal, so it feels really robust. And another optional add-on is the laser kit. So it comes with some laser safety goggles as well as a small laser module. And this is also something that I'll be covering in that second video. And with those optional accessories out of the way, the toolkit does come standard. It comes in this nice little case. And in there, you get some fixturing parts, as well as some cutting and engraving bits, as well as some useful tools that we'll cover later. And there's a generic accessory box. In here, you'll find things like the power cord for the machine, and in my case, some extra bits, as Makera was kind enough to send me those, as well as some extra clamps. In this box, you'll also find the emergency stop, which seems like a nice solid unit, some safety glasses, a USB cable, even more loose milling bits, which I'm not sure are actually standard with this machine, as well as this case for the wired probe, which has some adapters inside in case you're using a collet for a different sized shank. Then there's this really nice tablet mounting solution made of aluminum, as well as the manual probe, some small tools, and an extra limit switch. And then finally, in the last box, there are some sample materials that you can experiment with or complete some of their sample projects, and I'll show you guys later where to find those on their wiki page. Next, we can get into the machine setup, and before we even turn the machine on, the first thing we need to do is we need to set the input voltage. So in my case, in North America, I'm going to flip the switch over to 115 volts. Then at the back of the machine, we can pull away the protective sticker, plug in the power cord, and then we can also plug in some accessories like the emergency stop. These connectors are keyed, so they will only go in one way, and there's a threaded collar where you can just lock them down in place so they won't accidentally get unplugged. Then there's two ports at the back. One is a USB-C labeled data, and that will be connected to our laptop, and the other one is just a USB-A, which can provide power to something like a tablet. On the left side of the machine, you'll find a dust port, and I've 3D printed an adapter for a generic shop vac. I'll put a link to this adapter in the video description down below. I'll be attaching to the machine with some M3x8 socket head cap screws that I provided myself. In the future, I'm going to look into designing an adapter that will fit more shop vac hose sizes, but for now, this will just get me up and running pretty quick. Beside the dust port, there's also an air inlet for chip clearing, and this takes an 8mm hose, which is commonly found on these aquarium style pumps, and I happen to have one laying around from some of my laser machines, and I'll put a link to one of those in the video description down below so you can find one. And that air inlet gets ported down to this clear tube, which is fed into an adjustable valve. Pull out on the blue knob and rotate it left or right to adjust the airflow, and then you can point the nozzle down towards your cutting bit to clear chips. Now on the right hand side of the machine, you'll find a spot for 2 more screws. We'll unthread the ones that are already in the machine, and then there are some spare screws that are slightly longer that were in the accessory bag, and we can use those to attach the tablet holder. During the unboxing, I mentioned that I got the extended bit set. The standard tools come in a nice little case, but the extended set just comes all loose. Now, in order to solve the problem of organization, I designed one of these accessory caddies, and it will hold up to 30 of the Carvera Air bits. It also has pockets for some extra fixtures and clamps, and I designed the bit holder slots so that you can insert them at a 45-degree angle. And this is a little different from other solutions that I've seen, but I've found that it makes both sides of the label stickers visible, and because the bits are offset from one another, you can see all of the writing and all of the labels very clearly from various angles. In addition to all of the bits and the fixture pieces, if you have the laser module, that will also fit in this organizer caddy, as well as the wires and other small bits, collets, and adapters can fit in some of those tray slots. The organizer can sit flat on a table, or optionally on the back you'll find 4 holes, and this part is included as well as the hardware to get it mounted to the main body of the tray. And that mounting piece gets attached with the 4 screws directly into the back, and this part here will allow you to attach the entire organizer onto the tablet stand. I would suggest using the adjustable ball joint on the back of the tablet stand to tilt it upwards, and then you can use the expanding grip of the tablet holder to grip directly onto that piece on the back of the organizer. On that piece on the back, there's a lip that extends over top of the tablet holder to prevent it from slipping through. And included with the organizer is this bit staging piece, which we'll talk about a little bit later, but you can see it's labeled tools 1 through 5. If you guys are interested in supporting this channel and picking one of these up for yourself, you'll find them on my website, embracemaking.com. So now let's hook up the Carvera Air to our laptop. So we'll be using the included USB cable. The USB-C end goes into the data port in the back of the machine. Then we can use the power button to turn on the Carvera Air. And if your status light at the top of the machine is flashing red, that's because your emergency switch has been activated. So you're going to want to deactivate that by rotating it, popping it out. And now the Carvera Air should connect to your laptop, and we'll open the Carvera controller software, which you can find on the Makera website. With the machine connected in the top right hand corner, you'll find a drop down menu with several different options, including the option to connect the Carvera Air to your Wi-Fi network. Now I won't be doing that for this video as I'll have it directly connected to my laptop, but here you can also update the firmware for both the machine and the Carvera controller software, and in this case the current version for both of those is matching the latest versions. And you'll also find another menu with even more settings. Some of them are just basic settings, for example, controlling when the LED lights inside of the machine turn on and off, but there's also a section for some more advanced settings, and for this, we won't be touching those for now. I'll just leave everything as default, but if you are a more advanced user, you may want to make some changes. Now up at the top, you'll also see a bunch of other controls, and with these, you can zero out your X, Y, or Z axes, including the A axis if you're using the 4th axis controller. Up here, you can also directly control the spindle, check out the spindle temperature, and there's even a button to manually control the laser if you were to have that plugged in. In the bottom left corner, there's a button to upload G-code files. We'll take a look at that in a second. There's also a button to switch over to a G-code command window, where if you really know what you're doing, you can manually send the machine some G-code commands. On the right hand side, there's a button for a flyout menu where you can jog the different axes of the machine. So if you press the Y minus button, and I've got the increment set to 10 millimeters, it'll jog the Y axis towards the back of the machine by 10 millimeters. And if I press the Y plus button, then conversely, the platform will move 10 millimeters at a time towards the front of the machine. We can do the exact same thing with the X axis, but before you do that, just be sure that you've moved the hose and dust shoe out of the way. I'm just going to remove the dust shoe altogether and clip the hose to the front of the spindle. Then again, in the same manner, we can press the X plus button, and that's going to jog the X axis towards the right hand side of the machine. And hopefully, as you would expect, when you press the X minus button, it's going to jog the axis towards the left-hand side of the machine. Now, curiously, there is a limit switch on the right-hand side, but there is no limit switch on the left-hand side. So if you jog it too far over, it's going to give you some kind of an error, and it's going to tell you to reset the machine. If you happen to do this, don't worry, it doesn't seem to damage anything. The machine will just reset itself, and then upon restarting, both the X and Y axes will home themselves. Now, obviously, this whole thing is just a super simple and basic rundown of the setup of the Carvera Air, but Makera also gives you a quick start guide. And I would encourage you to take a read through that because it does cover a lot of the fundamentals, but even better, they have an amazing wiki page, which I'll link to in the video description down below. In my opinion, CNC machining can be very involved, and at least at the most basic level, I would say that it's still more complicated than both 3D printing as well as laser engraving. So I really appreciate the fact that Makera has gone the extra mile with their wiki page with a lot of great videos. And on the left hand side, if you click on the Carvera Air manual and scroll down, this is where you'll find links to all of their tutorial projects. Some of those projects look like fun, but you've probably already seen other people on YouTube cover them. So instead, I'll thoroughly walk you through 2 of my own projects. To get started, we need to open Makera Cam, and you will have seen that I selected the 3-axis option because we're not using the 4th axis. Now on the left hand side, you'll see a work coordinate system. That's what WCS stands for. And in there, you'll find a feature tree with the different images or 3D models that you might be uploading. But the first thing we need to do is up at the top, we're going to input the dimensions and type of stock material that we have. So in this case, I'm going to be starting with acrylic. So I've input plastic, and I'm going to change the X and Y measurements to match my acrylic panel, and the height, so the Z is going to be 4 millimeters thick. Then I can use the button at the top to upload an image, and in this case you can upload something like a PNG or JPEG file. And I'll show you how we can process this image to get to something that we can engrave. So we can select the image directly, or we can select it on the tree on the left hand side, and then we can use some of the transform tools to scale this, because as you can see, it's way too big right now. The transform menu will pop up on the right hand side, and we're in scale right now. You can see that there's an anchor point, and it's using the center of the image, so it's going to scale the entire image around the center. And then you can just put in a new X or Y dimension, and the other axis will get scaled automatically because the 2 are linked together. Then you can click on the move button, and you can select a new anchor point if you want to use that as your reference to move the graphic around. I used the bottom left corner of the graphic, and I've sent it down to the 0,0 position on the stock material. Alternatively, if you want your image centered directly on your stock material, you can go back into the move feature, and then you can choose the anchor point as the center of your image, and you can just press on the quick align stock. And by selecting the lower left anchor point, I could have technically done the same thing the first time around and pressed the quick align stock button to send it down to the lower left corner or the origin instead of typing the numbers in manually. In the bottom left hand corner, we can grab the little view cube and we can rotate the whole thing around. There's also some shortcut keys where you can change between select, pan, rotate, or zoom. And I do honestly find these controls a little bit clunky to work with, and I hope this is something that they improve in a future version of the CAM software. But regardless, we need to turn this image into some contours that we can work with. So we can right click on the image and then click on trace, and this is going to bring up some options. Now, I don't know what a deadline is. It's not entirely clear to me what this control is doing, but you do have some other controls that are more obvious, such as the threshold, the smoothness of the lines that are being created, as well as a slider to optimize the result. Now, obviously, this whole thing works better with high contrast black and white images. If you want to delete your original image after processing the contours, I could have checked that box, but I'm going to leave both of them here so that they're still visible and present in the feature tree, and I can just use the little eyeball icon beside the original image to make it disappear. Now all of the contours are visible. I can select each of them individually, and I could create some sort of toolpath around them. So that's how you would work with a regular 2D image, but you can also just import an SVG vector file directly. This would be my preferred method, as if the SVG file was created in another program such as Adobe Illustrator, all of those contour lines will be very smooth, as they won't be an interpretation of a raster image. So you can see I've imported this SVG file of the Millennium Falcon, and I'd already gone ahead and selected some of those contours and just pressed delete on the keyboard, and the ones that I didn't want were simply deleted. Now I'm going to create some toolpaths, and I can right click on the image in the feature tree and select the entire graphic, and then in the menu at the top, I can select a 2D contour. The menu with all of the settings will pop up on the right hand side. The depth for this 2D contour is automatically set to 1 millimeter, and I'm going to have to add a tool. So I've pressed the add a tool button, and the menu pops up, and it gives you a bunch of preloaded tools that are compatible with or provided by Makera for the Carvera Air. And this is where they've made things pretty easy for you because they've already input all of the tool properties, including settings like the feeds, speeds, and stepovers for the various bits for various materials such as aluminum, wood, and plastic. But just keep in mind that if the tool is in the list in the software, it doesn't mean that you actually have it or it was shipped with your machine. So just double check that you actually have the tool before selecting it in the CAM software. Once the tool is selected, a lot of these settings will be pre-populated, but you will have to select whether or not you're engraving or cutting on the inside, outside, or on the vector line. So in this case, I'm going to choose on the line. And the software right now is defaulting to climb milling, so I'm just going to leave that. But I will activate the ramping setting, and what this does is it slowly descends the milling bit or engraving bit into the material at an angle. So it doesn't just plunge it straight down. Drill bits are designed to be plunged, but oftentimes engraving bits as well as flat cutting bits are not meant to go straight down into the material, as this could either break them or increase the wear on them. Once I was done with those settings, I just clicked calculate, and now you can see that I've hid the original contour lines that were pink, and these white lines are the actual toolpath lines. And you'll see in the feature tree on the left hand side, we now have a toolpath called 2D contour. I had selected an engraving bit for that contour, but I do also want to show you guys for this example how to cut inside of a profile, and for that we're going to be using a single flute end mill. And to demonstrate that, I'm going to bring in one more graphic, so it's just the Star Wars logo, and I've specifically chosen this one as all of the contour lines form closed objects that we can mill or pocket inside of. So I've selected that, and then I'm just going to select 2D pocket. I'm going to type in the same end depth of 1 millimeter for the 2D pocket, and then I'm going to scroll down and I'm going to add the next tool. Back in the tool menu on the left hand side, I'll take a look at the different options, and I should be able to find something in the flat end section that's suitable for non-metal. So in the list, scrolling down, I'll want something kind of small so that I can get closer into the corners of the closed profiles. You have to think about this like a machinist. The bit is round, it's not infinitely small, so you can't get a perfect inside corner. It's always going to be a little bit round, a little bit radiused. So the bigger the bit that you choose, the bigger the radius in those corners. Now you can go with a very small bit, but if you do the whole profile with a very small bit, it's going to take a long time. In a lot of cases, the general strategy is to start with a larger bit and then do a finishing pass along the outside with a smaller bit to get tighter into those corners. But for this example, it's just a small acrylic sign and it's nothing too critical. So I'm going to go with a single bit and just carve this out. And for this pocket operation, I've got the offset selected as well as the inside out option selected. And I'll be ramping into this material. And for that, I've chosen 2 millimeters at a fixed angle of 20 degrees. I probably should have went to something a little bit larger than that, but it's only plastic, so it shouldn't really damage the bit too much. Once those paths have been calculated, you'll now see that there's a second path operation on the left-hand side, and we can actually grab those and reorganize them just by dragging them. The order of these paths from top to bottom is the order in which they'll be executed in the G code. Now we can select both of them and we can just choose export as we right click on them, and now this menu will come up and we can actually number the tool numbers if we want to change those. They're automatically numbered right now 1 and 2, and then we can export the G code file, which is a .nc file, to our computer, and this is where we're going to have to bring it over into the Carvera Air controller later. But before we do that, let's get the spoil board mounted. And inside of the hardware and toolkit, you'll find some of these short M5 screws, and we can use the included screwdriver. I'm also going to be aligning my acrylic panel with the first origin using this squaring tool here. So we'll put some M5 screws in each of the corners of the spoil board. And you can also see that I've mounted the squaring component with the same M5 screws in the bottom left-hand corner. Now I have my 4mm thick acrylic panel and I've placed it down into that bottom corner and use some of the other fixturing pieces here to hold it down and prevent it from moving during the machining process. Now the spoil board is down there, and typically that is to protect the actual bed from damage when you're doing through cuts. And although for this acrylic we're not doing any through cuts, I might as well just have it on there for future use. And some of these other fixturing brackets have small features that are not the same from one side to the other, so just take a close look at them as you're using them to see which edge or which corner can be used to fixture your particular material. Additionally, in the squaring brackets, there are some holes like this one that I'm tightening down here, which don't actually tighten the bracket itself down, but allow the head of the screw to just catch the edge of your material and keep it from lifting. And finally, before we machine anything, we should put some collars on our bits. Now there is this collar installer, and included with your Carvera Air, there should be a whole bunch of these small black collars. The collar tool will unthread and end up in multiple different pieces. I've put one of the pieces in the background aside that's meant for actually removing the collars, and right now you'll see that I'm taking the frontmost piece, I'm dropping one of the collars inside, and then I'm going to take the bit itself, and be careful, these engraving bits are extremely sharp, and I'm going to drop that into the front piece with the collar already inside with the pointy side facing down. Now there are these other sleeves that'll slip over the shank of the bit, and those will also fall down into that front piece. Now I'm going to unthread the large knob at the back to give this thing some room where I can thread the front piece in. The front piece should get threaded all of the way down, and some of that bit might start sticking out at that point, so again, be very careful, and at which point now you can tighten the large knob at the back, and that's going to drive the bit all the way through the collar, and it's going to seat it with about 12 millimeters or so of the shank sticking out the back. So essentially this tool will give you that consistent spacing on the shank so that it seats properly inside of the collet of the Carvera Air every single time. I went ahead and used the same procedure for the other bit that I'm going to be using for this job, and when looking at the two, again, you can see how the two shank ends are consistent. Now we can put them back inside of the bit holders safely so that our fingers are not at risk. Now I'm going to hop back into the Carvera controller software, and earlier in the video I already showed you how to connect the machine, and we're going to upload the G-code file. By default, when you go to open a file, it sends you to the directory for the Carvera Air itself, which hosts its own files. But you can click on upload in the top right hand corner, and you can navigate through your folder structures to find the G-code file. In this case, I've got my falcon.nc file that I've gone ahead and opened up. And then you can click the little gear icon in the bottom left hand corner of the screen. And this is the point at which my screen capture software decides not to really capture anything anymore. So you might not see a lot of movement right now, but I'll verbally describe what I'm doing. And there's actually not a whole lot for this particular example anyways. Because I'm using that squaring bracket in the bottom left hand corner, I already have the anchor 1 point set up. So the blue dot represents the 0, origin, which is the bottom left corner of my stock material, and I don't have to adjust it. There's also the bold green rectangle, which represents the scan margin, or the area that the graphic is representing. And then there's the 3x3 matrix of yellow dots, which represents the points that the wired probe is going to touch down on the stock material and measure the Z height. So after clicking run, the controller software will tell you to switch to the wired probe. The probe sits in a bracket on the tool head, and switching to the probe or other bits is very easy. You pull down on the large lever on the left hand side to loosen the collet, insert the new bit, and release the lever, and it's tight. Now you can see that the laser inside of the probe is going to scan the area of which it's going to probe, and this gives you one final moment to hit the emergency stop button or the software stop button in the Carvera controller to prevent the probe from crashing into anything if you notice that it's trying to scan, let's say, over top of some of your fixturing points. Once it's done probing the surface, you can go ahead and confirm that it's done. It's going to prompt you to switch to your first tool, and you'll see that I had my tools staged inside of my organizer in the staging bit holder. So I've got them labeled 1 through 5. In this case, we're only using 2 bits, so I'm going with bit number 1, which is going to be the flat end mill. I've got that one installed. I also put the dust shoe in because I'm going to be turning on my shop vacuum, as this is going to create a lot of plastic chips. And when machining plastic or wood, I would say that these are perfect candidates for the dust shoe, so we can vacuum up that excess dust or chips. Now, it doesn't seem that you can use the air nozzle and the dust shoe at the same time. They will interfere with one another if you try and point the nozzle down at the engraving bit, so you're just picking one or the other. After a few minutes, the first toolpath operation is complete, and the controller software will prompt you to change to tool number 2. The tool head will automatically return back to the home position, and the spindle will turn off, at which point you can safely change over to tool number 2. So I've returned to my organizer in the bit staging section. I've selected tool number 2. I have it safely loaded into the collet, and then I've put the dust shoe back on, and in the software we can click on confirm or resume. Now, if you're wondering how loud this machine is, I'm going to bring the audio in right now so you can have a listen. The machine is shockingly not that loud, especially with the lid closed, and in the second clip, you may have heard that I turned the shop vacuum on for the dust collection, and that by far drowns out any of the noise from the machining process. Now this job did take quite a long time to complete, as there were a lot of lines and details in that Millennium Falcon SVG file. In retrospect, I probably could have ran it at a faster speed and a shallower depth to get it done quicker, but as they say, hindsight is 20/20, and that also goes for this moment here, where I was vacuuming up the mess left behind by the machining process, and I made a very rookie mistake. I'd left the engraving bit inside of the collet while I was doing that vacuuming, and it clipped the top of my hand and it cut into my skin pretty deep. These things are extremely sharp. I mentioned that earlier in the video, and they will slice through your skin like butter. I definitely thought I was going to be in for 1 or 2 stitches here. It's hard to tell how deep it is from this short video clip, but luckily it's healing just fine. And my advice for you would be, before you remove your workpiece or do any sort of cleanup, please make a habit of removing your cutting bit from the collar, and that's step 1 before you put your hands back inside of the machine. But other than that little mishap, the result looks really nice. And despite the fact that I'd mentioned that this did take quite a long time, and it probably would have been more efficient to do this on, let's say, a laser engraving machine, if this is the tool that you have, you can get a very unique look with all of the machining marks present. The graphic also tends to look a little better when viewed through the opposite side of the acrylic. So if you do have something like text, I didn't do it here, but in the future I would mirror that text so I could view it in the proper orientation through the back of the acrylic. And lighting up your panel with an LED base makes it very attractive looking. In the video description down below, I'll put some links to where you can find these kits, where you'll get blank acrylic sheets with a bunch of LED bases for a really great price. Now this next example is going to be significantly more complicated, and this is the shape that I want to produce, and I want to make it out of aluminum. Now in itself, this circular shape, if I were to just do this pattern here, would be pretty straightforward. We've got a few holes, a circular outline or contour, and in the center we have a semicircular hole with a bit of a flat on there. But what's going to make this more complicated is the fact that there is a cross-drilled counterbore hole on this face here, on the circular face. So if we make this object transparent, you can see how it is a cross drill, and it goes down to the flat, as this whole thing is intended to be mounted on a motor shaft, and this hole here will be threaded, and it'll act kind of like a grub screw to grab onto the shaft. Now what this means is that we can't do this in one setup. I can't just machine this from the top, as obviously there's no way to get inside and get this hole. This is where CNC machining becomes a little more complicated than 3D printing. If this was to be 3D printed, I could just send this to the printer and I wouldn't have to think too much of it. Now, what you do have to consider when CNC machining is how you're going to fixture this and how I'm going to machine this in probably more than one step. So to get this final result, I'm going to have to go through several different stages of machining, and I figure that the first thing to do is I can in fact get these holes in the first step or stage of machining. And I will actually, instead of making a circular outer profile, I'm going to make a square. So I'm just going to bring in a shape. I've got a square, and it is tangent to the circular outline of the thing that I want to make, the final result. And you'll notice that it's not quite as thick, and that's because the intended circular shape is a 1/2 inch thick, and I've only got 11 millimeter thick aluminum stock, so that's what I'm going to be working with. And the thickness isn't that critical in this design, so 11 millimeters should be fine. And now this is where we're going to bring in some of the other features, and I'm going to try and explain how I'm going to fixture this in the Carvera Air to get to the final result. So one of the things that I've done is I've brought in the spoil board or the bed of the Carvera Air to start to plot out where I want to place this, so that I can use and leverage off of the fixturing holes. So you'll see on the bottom that I've lined this up with 2 of these holes, and this means that I'm not going to be able to use the standard fixturing origins. So I'm gonna have to create a new work coordinate system in Makera Cam, but that's a problem for the future. And so what I'm gonna do now is I'm gonna make the green shape disappear, and I'm gonna start to bring in some of the features that I need to machine into my square. And so you'll see this is going to be the first step file that I'm going to import into the CAM software. And you'll see all of these dowel pin holes are included in the shape, as well as the center hole. And you'll notice that there's an extra hole over here, and I still have my counterboard hole on top. And so when I bring this into the CAM software, I'm going to try and get all of this into the first machining setup, including this pocket here. And this pocket is going to be included for the next machining setup, where I'm going to turn this thing on its end and I'm going to seat it on this face. And then from the top, I'm going to try and machine this counterboard hole. And you'll see that it's actually not all the way through, because I don't think any of the bits will actually reach to go all the way through, but I am going to get the counterbore and I'm going to get this smaller hole here. And with this hole here, I can bring the whole thing into a drill press and I can just drill all the way through, and this smaller hole will just help me locate the through hole that I can get on the drill press. But essentially, I'm going to stand it up on this edge, and I'm going to use this pocket area here with this lip to clamp it down to the spoil board and keep it from moving. Now, in the final result, when I lay this thing back down on the same face and cut out the shape into its final circle, I will have this pocket, but this is part of the fixturing that is something that I can live with, as it's not going to impact the function of this part. And the explanation for this other hole here is you'll see where I have this thing lined up on the spoil board. So when I do go to cut this final circular contour after doing the second machining setup for the counterbore on top, I'm going to use the center hole, and I'm going to use one of the fixturing points with the M5 screws, and I'm going to use the second one here to clamp this thing down. And that's going to allow me to clamp it down as a square and then cut it into a circular final shape. And the heads of the screws included with the Carvera Air are 9.5 millimeters and in diameter. And so if we take a look of the heads of those screws, it's going to be pretty close. Now, it's not going to interfere, or shouldn't interfere if everything goes smoothly, with the contouring shape of the outline to get this final result. But even if it cuts into the head of the screw, I think it's going to be okay. I've done that in the past with one of my other CNC machines, and it's just skimmed the heads of bolts, and it doesn't really do too much damage, if any damage at all. So this is the plan, and let's see how it's going to work out in practice. So with that long-winded explanation out of the way, we can now go back into the CAM software, and I'm going to set up my aluminum stock. So I've selected the aluminum material. The height is 11 millimeters tall, and I've got enough XY in there to accommodate my design. I've also imported my 3D model, and that's a .step file, and I'm going to right click on the model, and I'm going to use the transform tool to rotate it to the orientation with that pocket facing up, and then I can use the other locating features or move features, such as selecting the bottom left anchor and then moving it around. And I'm going to move it not in the center of my stock, because I don't want to just cut through the middle of this piece of aluminum. I want to be able to cut more than one of these if I happen to make a mistake. So I'm going to move it towards the bottom left corner of the stock material, but I'm going to leave some space for fixturing. So I'm going to add a little bit of offset or buffer, about 10 millimeters from each edge. Now we're going to be working with a few different tools than the previous example. So I'm going to start off with a 3D pocket, and I'm going to select the face that I want to pocket down into, and that's going to set the depth automatically. Now keep in mind here that my model is the exact same thickness as my stock. Had the stock been higher than the model, it's still going to pocket down all the way to the intended face. Generally, when we're dealing with CNC machining, your Z0 is the top of your stock material. Then we can add a tool, and for this operation, I'm going to go with a flat end mill intended for metal, And I want to make quick work of this pocket, so I'm going to be using the largest end mill that I have that came with the Carvera Air, and that's an 1/8 inch bit. Now for some reason, by default, the step down option is not automatically selected, so we are going to select that, and it seems to be preset to 0.2 millimeters of step down or cut depth at a time. So we'll leave that for the default setting for aluminum. Probably could go deeper than that, but we'll keep it conservative, as well as leaving all of the other default settings. But I'm going to make sure that for a pocket cut, I'm going to be cutting from the inside out, and I did add some ramping so that we're not plunging down into the material directly. Now I'll move on to the next operation, and it's going to be a 3D contour. And the difference generally anyways between contour and pocket is when you're not going all the way through the material, and contour, and I'm speaking generally here, but it's when you want to go all the way through the material. So I selected the bottom face, and this is very important. Do not select the top face. By selecting the bottom face, it's automatically going to set the depth for the entire material. And then I had clicked the Generate Contours button, and I had selected and deleted the outer contour. I just want to do the inner holes. And there's a very specific reason for this, and I'll explain that in a moment. But with those inner holes selected, I've also selected the tool, which is going to be the same 1/8 inch flat end mill bit. And the cutting strategy here is going to be an offset cut. And this option becomes available when you click the little pocket checkmark box. And the reason that I'm selecting that for these inner holes is that I want all of the material removed. If I didn't select the pocket box, then it's just going to follow the inside of those contours. And I felt there might be a risk of a tiny amount of aluminum that's left over jamming up against the end mill and getting it stuck. But by pocketing all of that material out, this eliminates that risk, and I don't have to add any sort of tabs or anything to the inside. And for those operations, I also added the ramping once again, and now we're on to the next 3D contour. So I'm going to select the exact same bottom face, I'll generate the contours, and this time I'm going to select and delete the inner holes, and I'm going to leave the outer perimeter of the square. And this is the contour that's going to cut out the entire square piece. So I've added a small end depth offset of about 0.5 millimeters, and that's going to tell the machine to cut 0.5 millimeters past the bottom face to ensure that there is no aluminum skin left over. And for this operation, I'm also going to be using the same 1/8 inch flat end mill. And in the cutting strategy options, I'm going to select to cut on the outside of the contour. I won't be using the little pocket checkbox. And for ramping, again, I'll add a little bit of ramping. And at the bottom, there's also another option for tabs. And this is going to automatically generate some tabs so that it leaves just a little bit of material behind, so when the square is cut out, that it doesn't get ejected or get jammed up against the end mill and cause any problems. At least not if you do it correctly. You can control things like distance between the tabs, as well as the tab thickness and their width and even their shape. Now for this one, I had left it at the triangular shape, and I would not recommend this for perhaps aluminum. Maybe it's okay for plastic or wood, I'm not sure, but it was the default setting, and I wouldn't do this again in the future, and I'll show you why soon. In retrospect, I also would have left the tab thickness at 1 millimeter. I had reduced it in an effort to make cutting those tabs off later a little bit easier, but again, you'll see in a moment why this was a mistake. So I've generated that toolpath, and things are looking pretty busy, so I'm going to hide all those toolpaths in the tree on the left hand side. And then I was trying to add one more 3D pocketing operation, but I did notice that sometimes in the CAM software, it locks you out from adding a tool, and you have to save your project and then restart the software to be able to add a new tool. I think this is some kind of bug or glitch, so I'm hoping that Makera fixes it in the future. But with the software restarted, I was able to go through the same process, and this time for a tool, I needed to add a smaller flat end mill, this time a 2 millimeter tool, in order to get inside of those holes, because an 1/8 inch bit would have been just too big. So for this job, we have a total of 4 separate operations using 2 different tools. In the tree on the left hand side, you can see that I renamed some of these and I dragged them around, and the last operation will be that outside contour. So I've ordered them according to, at least logically in my head, what I think makes sense. And now, just as we've done in the previous example, I can select all of these toolpaths, right click on them and click export. And now in this final window, you can change the tool numbers. And I noticed that also in the CAM software that at least during the stage where you're creating the different operations, sometimes different tools will still default to the same tool number, so you have one last chance to sort yourself out here. Now I have my 11mm thick aluminum plate fixtured into the second origin position, and I'm using a number of different fixturing pieces here, probably a little bit overkill, but at least I know that it's not going to go anywhere during the machining process. And before we head into the Carvera controller software, I'll just preemptively install the probe because I know that we're going to be using this in a moment. Inside of Carvera controller, I've imported my G-code file, and you can see all of the toolpaths here highlighted in green. Then I'll click the little gear icon in the bottom left-hand corner, and we'll go through some of the origin setup. So you can see again, my screen capture software didn't record any of this part properly, but in the configuration for the work origin, I've just selected anchor point 2, and then I've got that blue dot representing the bottom left corner of my stock. The bold green square is going to represent a boundary of all of the toolpaths, so they're all contained inside of there, and that square is going to match the square outer contour. That's going to be the outermost contour that we're going to be machining. And its position seems to match what we had set up in the CAM software because it's set up to be about 10mm offset from each edge of the stock material. I also have the auto leveling and scan margin selected. The auto leveling measuring points are those yellow dots, so when we click run, the machine will go ahead and probe those exact points on the top of the stock material. Once that's done, we can load in the first bit, and this is going to be, in this case, the 2mm flat end mill. And since we're machining aluminum, I'm going to be using the air nozzle. I've got it pointed directly at the tip of the tool, and that should help clear out some of those chips. So I've gone ahead and also turned my air assist module on. And I can begin running this job by clicking the button in the software or at the top of the Carvera Air above the LED status bar. There is a single button that you can confirm that you're ready to go. This 2mm diameter end mill is only 8mm deep, at which point it flares out to the full 1/8" shank. So if you're new to machining, just consider that if you're using one of these tools, you won't be able to mill deeper than 8mm, otherwise you're going to come into contact with the shank. Later I'll use these as drill guides with my drill press to drill all the way through this material, and in the future I'll invest in a full collection of drill bits to use with the Carvera Air for drilling operations. For the remaining operations, let's have a listen to what the machine sounds like with the 1/8" bit cutting through aluminum. Once the final contour operation was complete, this is what I was left with. Unfortunately, I didn't capture this as it happened, but obviously the tabs tore out and the part was at least attempted to be ejected by the bit, but it all got wedged in there. So that's why earlier during the CAM process, I had spoken about using thicker tabs as well as not using the triangular tabs. In terms of tolerances, the machine seems to be quite good. The nominal dimensions from face to face was supposed to be 41.1mm. And measuring with a decent caliper, I'm just seeing a few hundredths of a millimeter over that in each axis. And as for this small amount of damage done from the part ripping out, I'm not too worried about that, as we're going to be doing some more operations on this thing and it should get cut off. So we'll get this part refixtured for the second machining setup, and one thing that I didn't mention earlier was also included in the toolkit are these dowel pins. If you want even more precision, you can use those locating dowel pins with the corner fixtures to ensure everything is in the correct place. Now to get our part fixtured a second time, I'm going to be using the pocket as I had described earlier with the side clamp. So I'll stand the part upright and push it into the corner of this bracket, and then I'll use the side clamp to clamp down on the edge of that pocket. Now from the right hand side, I'll use another side clamp just to kind of box it in and make sure that it's really not going to go anywhere. In the CAM software, I'll set up the stock material to represent the new orientation of this piece. It'll be 41.1 millimeters wide as well as 41.1 millimeters tall with a thickness of 11 millimeters in the Y direction. I'll import the same step model that I did in the first machining operation, but I'm just going to flip it up on its end so that it again matches what we've done inside of the Carvera Air. And now I'm again going to be using the 3D pocket feature, and I'm going to select the first counterboard face. And just as before, this is automatically going to set the machining depth. And I'm going to select the same flat end mill tool that has a 1/8 inch diameter. Then I'll click on the step down checkbox to ensure that the bit doesn't plunge all the way to the final depth. And then one other thing that I noticed is that we can change the tool number right inside of this operations settings window. So I've went ahead and changed that from 4 to 1. And for this pocket, I'm going to be selecting an offset, and I'm going to change it from outside to inside. Now normally for pockets we do inside to outside, but I'm changing it because this is a small pocket and I want to do some ramping to enter into the material. And by going outside to inside, we're working with a slightly larger path that perhaps we can do a more gradual ramp into the material than if you had gone inside to outside. At least that makes sense to me in my head, but we'll see what actually happens. That path is now done, and now I can click on the face at the bottom of the tap drill hole, and I'll be creating another pocket with the same tool. First operation will have cleared out a bunch of material, so I actually set the start depth to 5 millimeters, so we're not going to be wasting too much time machining air. And using the rest of the same settings, you can see when the path is created, and I've hidden the first one, that the actual path starts well within inside of the first counterbore. On a single hole like this, the time savings is going to be minimal, but you can imagine if you had a larger project with many more holes, the time saved starts to add up. Now we can take the exported G-code file, bring it over to the controller software, and again in this configure and run window, for whatever reason, my screen capture software just doesn't like this, and it's not capturing everything that I'm doing. But regardless, I've got it set up with the second anchor point, and we'll just probe a few points on the surface, and you can see all of those points are limited to exactly where the counterbore will go. So at this point, this setup is pretty straightforward, and we can just click on run. 9 points in that small area will be probed, and unfortunately there's no other way, as far as I can tell, to reduce those number of points, at least when using this auto leveling feature. Then I can switch over to the single tool that we're going to be using for this job and let it run. And you can actually see my reflection in this front cover because I was very carefully watching this go down. I had some concerns that during the machining process that the tool head machining at the top with the block standing up like that might cause it to get forced over since it has more leverage on the fixturing below. But luckily this didn't seem to be the case, and everything turned out just fine. And while I'm pulling this thing out of the fixture, I will just also mention that due to the limited length of the bits that I have, I wasn't able to pocket all the way down into the center of the part and pierce through the center hole where the motor shaft will eventually go through. I'm just going to use that shallow hole as a drilling guide because now I'm putting it on the drill press, and I'll use a longer drill bit to complete the hole for the M5 screw. And the final thing to do for that hole would be to take the M5 tap and complete the threads. Now the smaller holes are also going to act as drill guides, and I'm going to drill those out all the way through the part with a 1/8 inch drill bit. Eventually in those holes I'll press in some spring pins. So far so good, and we're on to the very last machining setup, and you can see I've imported the second step file. So this one is the one where the outer contour is going to be round. And this will finish off the part, but we are going to need to create a second work coordinate system. So I've gone ahead and added one, I've renamed it, and I've selected the center of the part as the origin. If you recall from when I was showing the CAD model, I'm going to just take the measurement from the corner of the first origin system to the center of this part here, and then I'll have my X and Y measurements when we move into the controller software. But for now, we don't need that information. For now, all I need to do is select the 3D contour operation. I'm going to select the bottom face. I'll create the contours, and I'm going to just delete everything except for the outline of this part. Then I'll go ahead and select that. The end depth is automatically set to 11 millimeters, which is the entire thickness of the part, and that's also what I set the stock thickness to. And for this operation, I'm going to be using another 1/8 inch flat end mill. I'll be enabling this step down, and then in the machining strategy, we're going to be machining the outside of the contour, and we'll be ramping into this part. Now, when it comes to tabs, we're not going to add any tabs because I'm going to be fixturing this part to the spoil board using the hole in the center and the second M5 clearance hole that I created. And there will be no additional clamps holding this thing down. So the little corners that are going to get machined off of the square, those can go flying off in any direction, and I don't really care. I think it should be totally fine. So that's it for this last setup, and we can just export the single toolpath, and then we can take a look at the fixturing setup, which I just briefly described. So we've got the square, and the only thing that I'm going to do here is use this corner bracket to ensure that it is aligned properly, but technically that center hole is going to be the origin, and that's the 0, 0 position of our work coordinate system. And I just used a ruler to measure to find a single point that I can probe using the probe. So I figure about 10 millimeters up from the center should be a safe probe point. So with all of that said, in the config and run section of the controller software, I clicked on the config button for the set work origin, and this is where I can set that X and Y offset that I'd measured in my CAD software. Now again, the screen capture software didn't capture this properly, but I would have just typed it into the X and Y offset from anchor 1. And then when it comes to probing the top of the surface, this is where I had just spoke about measuring a safe distance from any of those screws, so about 10 millimeters up. And so I've disabled the auto leveling so it doesn't probe 9 points, and I've just left the auto Z probe enabled. And again, unfortunately, you can't see me do this live, but I would have clicked that config button, and I actually set it to 0 and 12 millimeters instead of 10. I gave myself an extra 2 millimeters just to be safe, and that's the red dot that you see on the screen. That's where the single probe point is going to happen. So if I've done everything correctly here and have it all set up, then during this laser outlining portion, you'll see that the laser just skims all 4 edges of the square, which looks good, and it's going to go and probe 12 millimeters up ahead of that single bolt in the middle. So right now everything's looking great and the setup looks reasonably accurate. I'll now swap the tool over to the end mill and we can get things started. If you're machining aluminum, especially with the air nozzle on, I would highly recommend that you keep the front cover closed because it gets very messy. The aluminum chips are pretty fine, they fly around everywhere, and the air nozzle does a very good job of keeping the cutting bit clean. At the end of this operation, I was very pleased to see that these 2 screws were enough to hold the part in place without any movement, at least not from what I could see. Fresh off the machine, the part looks very good, and there's only some very minor nitpicky stuff, like some minor flat spots on the left side and the bottom, but that's on me because I didn't get the alignment absolutely perfect. But ultimately, it doesn't really matter because outside round face of this part isn't part of its function. Off screen, I just took one of the included sanding blocks with the material kit and I sanded all of the surfaces to give it more of a brushed look. And now the part looks even more uniform and all of the edges have been softened so they're not quite as sharp. But better than a sanding block, if you guys get one of these machines, I would recommend that you get a deburring tool, and I'll put a link to one of those in the video description down below. Lastly, you can see this part in its final resting position, and the center hole in that D shape fit absolutely perfect on top of the motor shaft, and I now have a properly robust part for my mini wire bending machine that is no longer 3D printed. So now my final thoughts on the Carvera Air. So first, let's take a look at the hardware. And I think you're getting a lot of machine, especially for something that fits on your desktop. For example, it's got the die-cast aluminum frame, 20 millimeter linear rods on both the X and Y axis, closed loop motors, as well as a spindle that reaches up to 13,000 RPM. And I think this is all very impressive. In addition to those more structural hardware features that I just mentioned, it's also very tech feature rich.
So things like the auto probe, I really loved. The fact that the probe uses the laser to sort of project the bounds in which you're about to cut or engrave, that is amazing, and it really puts your mind at ease that you're not going to crash your tool head or the probe into any of your fixtures. I also really enjoyed the full enclosure. It cuts down a lot on noise as well as just general mess, and having the dust port as well as the air inlet were amazing to see as well. That's all built in, and these are some things on other CNC machines that you have to add on later. But just keep in mind that even though the ports are there, things of course like the shop vac that you're going to use for dust collection, you're going to have to supply that yourself or budget for it if you don't already have one. Personally, I'm just using a very affordable, cheap shop vacuum, and I'll link to that in the video description down below. I've made previous videos where I've shown that I've actually created a HEPA filter adapter for those very cheap shop vacuums, and honestly I'm just using some paper towels wrapped around the HEPA filters to act as a pre-filter so that things like aluminum dust when you're machining don't very easily clog up the HEPA filter, and you can just swap out the paper towels very quickly, and of course those are very cheap and affordable. Continuing with the hardware, the other thing that I really love is the quick change tool system. In the past, I've had a desktop CNC router, and fiddling around with the wrenches and all that was very frustrating. Just having this lever to change out the bits is amazing and very convenient. The 4th axis attachment is also very impressive for a desktop CNC, and that's something I'm really excited about working with in a future video. This video just got a little too long, and I had to bump that to a second video. In terms of the hardware, the only thing that really left me wanting for more was the fixturing equipment that came with the machine. I felt like the options were slim and a little weak, to be honest. I felt like they could have included even something as small as a little mini vise that could fix itself to the machine table. And speaking of the machine bed or table, the other thing on there that I thought could be improved was having more fixturing holes. There's a bunch of them there, but they're kind of spaced far apart, and if you're looking to do more things, I just felt like there weren't enough options to fixture things very conveniently. Moving on to the software, I felt like this is where the biggest improvements could be made, and that's not such a bad thing because, of course, software can be easily updated, downloaded, and that sort of thing, whereas hardware, if it's just bad or subpar out of the box, that's not something that you can easily improve. That being said, I think the software is a good starting point. Don't get me wrong, I'm not trying to say that it's bad, it's just fairly basic. And I would imagine that Makera is going to add more features to the CAM software specifically in the future. Software updates tend to also fix things like bugs and other issues. If you guys watched earlier in the video, I thought maybe I had found one where I was having an issue adding a tool to some of the 2D or 3D paths, but I'm not sure if that was just user error. The controller software is also pretty basic, but it does get the job done. And the most important thing here that at least I found was that both the CAM software and the controller software was more or less pretty intuitive to use. It wasn't too complicated, which makes the whole thing very easy for beginners to get started. And the other great thing is that if you are a more advanced user, you are welcome to use third-party CAM software to make all of your tool paths, and the output is just regular G code. So there's no proprietary file types that you need to send to the machine. You're welcome to use any third-party software you want, and the machine is very open that way. So I thought that was a huge positive. And the other big positive is Makera's documentation. Their wiki page is excellent. They've got a ton of different articles on there tackling everything from the most basic tasks to more advanced tasks. And the thing that I really love is that they've broken it down into small little videos. And if you're a beginner, this helps to keep you from becoming overwhelmed with too much information all at once. And if you're a more advanced user, it's also good because if you just need a quick refresher on something, you can just reference a short little video and you don't have to sort through a very long video to find what you're looking for. Overall, I think this machine is perfect for hobbyists looking to get into, of course, CNC machining or producing heavier duty parts. So for example, I do a lot of 3D printing, but I do have some applications like e-bikes or e-scooters that I want to customize, and 3D printed parts for the drivetrain, let's call it, is just not feasible. And being able to make aluminum mounting brackets is going to be game changing for me. Now, when it comes to tolerances, that is yet to be determined. I took some general measurements and overall it seems acceptable, but I would just warn you guys or caution you guys, don't think that you're going to get precise tolerances like you would from a giant mill. At the end of the day, it's still a desktop CNC machine, and you should have realistic expectations, and that also includes the speed of the machine. If you're doing things like softer materials, wood, acrylic, plastic, whatever, it'll go through those pretty quickly. But if you're doing aluminum, you're gonna have to take light passes, and this is just the nature of having a smaller machine. I'm personally now very excited to have the Carvera Air as part of my collection of tools, and if you guys are looking to add it to your shop, use the links in the video description down below. They are affiliate links, but they will cost you nothing extra, and they go a very long way to helping to support this channel and making these very in-depth and thorough videos. If you guys already have the Carvera Air and you're looking to still support this channel, you can find that tool organizer on my website, embracemaking.com. I'll also put a link in the video description down below. But if you head on over to my website directly, there you'll find, of course, the organizer, and in the future, I plan on developing more accessories and upgrades for the Carvera Air, so you can just go there directly and check to find the latest and greatest stuff. Thank you guys so much for watching and making it right to the end of this video. Be sure to hit the subscribe button, hit that like button if you like this thorough content, and of course, check back in the future for the second video in this series featuring that 4th axis attachment. See you guys next time.